Hi everyone. So today we are expanding on the idea of inheritance, which we looked at a few lessons ago, and we're looking at what we call sex-linked traits today. Okay, so just getting my paper ready. There we go. So yeah, we're looking at what we call sex-linked traits. So far when we've looked at inheritance, we've been looking at inheritance of genes on what we call the autosomes. So the autosomes are all of your chromosomes except for the sex chromosomes, okay? But the 23rd pair of chromosomes are the sex chromosomes. And for that, the inheritance works slightly differently. So the sex chromosomes can either be X or Y, and as you're probably aware, XX codes for results in a female, and XY results in a male. So using a Punnett square, I'm just going to show you why there is always a 50-50 chance of a baby being male or female. So I've got the egg along the top there, and an egg will always pass on an X chromosome. So X or X, it will always pass on an X chromosome. Whereas the sperm can pass on either X or Y. So all sperm have one X chromosome and one Y chromosome. All sperm can either have an X chromosome or a Y chromosome. And then when that fuses with the egg, that's what causes male or female to happen. So as you can see here, if we reading the Punnett square, we go down for this one across to this one. So this offspring would be a female because it's XX. So would this one because it's XX. Whereas the two on the bottom would be XY, so they would be male. So that's why there's always a 50-50 chance of a child being male or female, because yeah, there's a 50-50 chance of the sperm carrying the X or the Y chromosome, essentially. So what we are really looking at is the idea that for sex-linked traits is we're looking at traits that are carried on a sex chromosome, and inheritance for them will work slightly differently. So the example we're going to look at is colour blindness. Okay, so colour blindness is a sex-linked trait, and the gene for that is carried on the X chromosome. And colour blindness is more common in males, which is common for many sex-linked traits. So what we'll say for this is we'll say that a capital B, which is the dominant allele, represents normal vision, whereas a lowercase b represents being colourblind. So that's the recessive condition. So capital B, normal vision, lowercase b, colourblind. We're going to imagine that a female carrier breeds with a male who has normal vision. So just in case you haven't heard that term before, a carrier is somebody who has an allele for a genetic condition, but doesn't actually have the condition because they've also got a dominant allele for not having the condition. Okay, so what I've done is I've written the woman's alleles here. So she has X carrying a capital B and X carrying a lowercase b. So she's not colorblind because she's got the allele for normal vision, but she does still carry the allele for colorblindness, so can pass that on even though she's not colorblind. The male, whose chromosomes are up here, just has X capital B and then just the Y chromosome because the allele is only carried on the X chromosome. So the crosses of this are this female will not be colorblind. She has two alleles for normal vision. This female, X capital B, X lowercase b, she would also not be colorblind because even though she's got the allele for colorblindness, she also has the allele for normal vision, which is dominant. Therefore, she will not be colorblind. This male will also not be colorblind because he's got the allele for normal vision. However, this male will be colorblind. And this is the reason why these sex-linked traits carried on the X chromosome are more common in males. If you compare this male to this female, both of them have the lowercase b, so the allele for colorblindness, but the female has a chance of getting the dominant allele in her other X chromosome. Males only have one X chromosome, so if they have the allele on that, they will have the condition no matter what. Whereas for females, if it's a recessive trait, if they have the dominant allele, they won't have the trait. So that's the reason why these sex-linked traits are more common in males, although they're not only found in males. So another sex-linked condition is called haemophilia, and haemophilia is a blood clotting disorder. So what I've got to represent it here is, again, I'm doing a capital H to represent not having haemophilia, and a lowercase h to represent having haemophilia. So the first example that I'm doing is having a female who doesn't have haemophilia breeding with a male who does have haemophilia. So the female is X capital H, indicating both X chromosomes carry the allele for not having haemophilia. The male is X lowercase h y, indicating that he does have haemophilia. This will actually result in no offspring having haemophilia. Two of the females will pick up the allele, and therefore they'll carry the gene for haemophilia, but they won't have it because they've still got the dominant allele. Whereas the two males, they pick up the X chromosome that doesn't have the haemophilia, so nobody in this situation would get haemophilia. It is also possible for females to get sex-linked traits, and here's just an example that I've done. So if a female carrier was breeding with a male who did have haemophilia, you can see there is a chance that a daughter could pick up haemophilia. So it can happen. But it's just more likely not to, because like I said earlier, females get two X chromosomes, they have that chance of getting the dominant allele as well, but it's not impossible for them to get sex-linked traits. So we normally talk about sex-linked traits as being traits carried on the X chromosome. There are sex-linked traits that are carried on the Y chromosome, but we don't tend to look at them as much because they're very predictable. Males always get them. Only males get Y chromosomes, and only males, and they only get one Y chromosome. Therefore, if there's a Y-linked trait, they will get it. So there's no real Punnett squares or diagrams to do for that. It's pretty simple. So that just overviews the idea of that. I know it can be a pretty complex topic, but take your time, go back over the video, have a look at the slides, and of course, if you want me to go over it in any more detail, please do log into Zoom at any point. So move on to the worksheet after you've watched this, and yeah, let me know if you need any help.